Okay, so to find the net work or the total work on an object, we want to know this. We want to know whatever direction the distance is going or displacement, right? Then we're going to make a coordinate plane with 0 in that direction. Then go counterclockwise 90, 180, 270. Only when you see a problem similar to this. So we have multiple forces acting on it, but they tell us that the displacement of the object is 5 meters to the right. So by going like this, by going 5 meters to the right, I'm going to make a little coordinate plane off the side. Since distance was going to the right, I make 0 going to the right, and then counterclockwise, fill in 90, 180, 270. 90, 180, 270. All right, so work, the equation for work is force times distance times cosine of the angle. What is the force for the normal force? The normal force is 20. The distance is 5. All right, this whole thing is getting moved to this direction. And what angle, all right, is the 20 Newton normal force going to? It's going towards 90. What angle is the applied force going to? Applied force is going to the right, which would be 0. What direction is gravity? What angle is gravity pointing down towards? 270. And then fill in their forces. Normal is 20, applied force is 10, gravitational force is 20, and the distance this object moves in total is 5. So they're all 5. Okay, then on our calculators, what we're going to do is just go on here and we're going to take force of 20 times the distance times. Now on this calculator, if you have this one, you can just then do the same thing and hit cosine. All right, so you can do 20 times 5 times cosine. Once you get the angle, you're just going to type in the angle. So the first one would be 90. On this calculator, you have to find the second button and see where it says trig in yellow. You got to hit that button. Scroll over till you hit cosine. Type in the angle, 90. Hit equals. Hit 0. Hit equals over here. Hit 0. All right, sweet. Answer there is 0. The applied force. I'm not going to retype this whole thing because if I just hit over on the arrow and go right over the 9, and now I can change the angle. To this, I can hit 0. I don't want a double 0, so I'm going to hit the delete button there. Hit equals. Oh, sorry. Never mind. I had to change this one. This one has got to be 10. So 10 times 5 times cosine of 0. And this would be 50 joules. You had negative 50. So if you accidentally typed in 180, then it would come out that direction. Or if you may have accidentally typed in... Okay. So the next one, 20 times 5 times second trig, cosine of 270 equals 0. And so the final thing you got to do is add up all of those pieces. So 0 plus 50 plus 0 is a total of 50 joules, and that's the total work done on the object. Boom, done. All right. Yep. Next one. What direction is this thing moving? It's going 5 meters to the right, so draw this in. D is 5 meters going to the right. What direction is distance moving? Make your coordinate plane. Distance is moving to the... So we're going to make 0 to the right. Go, good. Yep, 90 up top. 180 to the left. 270 down. Okay, angle. What angle is the normal force going? To 90. What angle is gravity going? Good, 270. And what angle is friction going? 180. All right, so again, now what distance did it move? It moved 5 meters. So again, we have our F times D times cosine of the angle. D is the same for all of them. So 5, 5, and 5. What is the normal force? 20. Gravitational force? 20, and friction force, 10. All right. All right, so throw these in. Bless you. Going 20 times 5 times second. Trig. Cosine of 90. 0. Oh, wait a minute. Let me do this real quick. Second. Trig. Cosine 90. The cosine of 90 is 0. So anything times 0 is 0. All right. And what other one was 0? The 270. So I'm going to do cosine of 270. What does that equal? 0. So I'm going to just add this down at the bottom. Cosine of 90 is equal to 0. And cosine of 270 degrees is equal to 0. So any problem where you have something times cosine of 90 or times cosine of 270, answer is going to be 0 for that. So right there, 270. I know it's going to be 0, and right, because we just did it in the calculator. Cosine of 270 is 0, so 0 times anything, it doesn't matter. All right, but we got to do this last one. We got to do the friction. So 10 times 5 times second trig over cosine 180 comes out to be, this case, negative 50. So add all those together. 0 plus 0 plus negative 50, and the final answer there is negative 50 joules. Yes, sir. All right, let's take a look at this one. Distance to the right. Make my coordinate plane. I know the distance to the right, so 0 is going to the right. Go counterclockwise, 90, 180, 270. Fill in your angles. Normal force is going towards what direction? Yes. Applied force is going towards what direction? 0. F grav, gravitational force is going what direction? 270. And friction, 180. Okay, again, work is force times distance times cosine of the angle. The distance moved is 5 meters in these. So we're going 5, 5, 5, and 5. Write down the values. Normal force is 20. Applied force is 10. Gravitational force is 20. Friction force is 10. Cosine of 90 is 0. And cosine of 270 is 0. So this and this, I know are going to be 0. So 10 times cosine of, or 10 times 5 times cosine of 180. Hey, this comes out to be negative 50. And cosine of 0, 5 times 10 times cosine of 0, this is positive 50. Correct. So when I add these all together, the total work on the object is not positive 50, it's just 0. Because positive 50 plus a negative 50 is going to be 0. So the overall net work done on that object is 0. Because you have friction applying is doing work on the object. The normal force is technically doing work on the object. You have gravitational force doing work on the object. Now, those two happen to be 0, but your applied force and friction force. All right, remember when I said if force and distance are in the opposite direction. We said this yesterday. If force and distance are in the opposite direction, so friction is going to the left and displacement or distance is going to the right, that's negative work done on the object. Applied force is going to the right, distance to the right, that's positive work done on the object. So if we're isolating for a specific fork, if we wanted to know just the work done on the object by the applied force, it would be 10 newtons times 5 times cosine of 0. In this case, they wanted the total work done, but that's how you do it. Okay, this last one here, you guys want to try this one? You can, but I want to see, let's take a look at this one right here. So 2 kilogram object, right? It's getting pulled up by a 20 Newton force for a vertical displacement of 5 meters. So what direction is the distance in this one? Yes. So we're going to draw a little up arrow on the side. Say that D is 5 meters. So now make a coordinate plane. What direction is D going? It's going up. So we want to make the up 0. Go counterclockwise, right? So leftward, kind of circle. 90, bless you, 180, 270. All right, so in this case, the tension, what direction is tension going? What's its angle?
0.
Good, 0. Grav, what's grav's angle? 180. How far did they move? Distance is 5 meters and 5 meters. What's the, all right, force of tension here? The force of tension is 20 and the force of grav is 20. So if we type that into our calculator, 20 times 5 times cosine of 0, that's 100. And if we want to do cosine of 180, and this is negative 100. So to find, when you're looking for total work, you got to add up the work done by all the forces. And this comes out to be 0. I want you guys to do F on your own. And I would like you guys also to do letter D on your own. Okay?